So this month we have Isaac Freeman. Isaac received degrees in French history and modern European studies from the University of Haifa, as well as an associate's in electrical engineering from Israel Institute of Technology. Isaac is a firm believer in the separation of humanities from applied and well, I completely cut off the rest of that sentence. I think that should say that
separation shouldn't be.
There should be no separation between humanities and applied theoretical sciences. In this lecture, we'll examine myths and facts regarding the medieval scientific thought, the methods of which people of that period used, as well as their pre-Copernican cosmology. We will also talk about how some of that knowledge corresponds with modern issues in science and pseudoscience. So this is an active participation one. I guess I should have read beforehand. So with that, turn it over to Isaac.
Good afternoon, everyone. So I didn't know if I need to present myself, but Carl already did. So we can go straight ahead to the presentation. I will show the agenda of what I'm going to talk about today. So if you have a question that might be answered later, wait with it. If it's something that can contribute, feel free. I'm not going to just give a lecture and have everyone listening. That's not the idea. I usually do those presentations in front of younger students, the age of 18, 20, and this is part of what I do. I want them to participate, to learn how to ask questions. I guess people here already have their degrees. They know how to do that, but still, remember, it's been recording to YouTube. So people who listen to it online would learn how to ask questions. This is part of what I'm going to talk about today as well. So I decided, I chose to use this photo to start discussing medieval science. Can anyone guess what it is? I mean, it's pretty obvious.
I mean, they're probably measuring the position of the stars.
Yeah, this is like practicing astronomy. We can see the stars in the light, the, how it's called, the armillary sphere. I will discuss it later in better photos of it. And there is something that I want to start with, just to make sure there's no confusion. The only time I will use the word witchcraft will be now. I will not use it throughout the lecture. It has nothing to do with medieval science. It has something to do with other things, medieval time and Renaissance, but that will not be part of the lecture. So what is the agenda? So first we'll just define what is the Middle Ages, because there is no clear definition regarding them. Then we talk about the liberal arts. Maybe some of you know how they used to be. They're not as today, which is just, humanist subjects like history, philosophy. It was much more than just that. What is the idea of science and what are scientific methods used in the Middle Ages? And also a short note, I will use the word science a lot, even though it does not apply to anything before like 1800, more or less. What is their logic, how they approach mathematics in general. The shape of the earth, which is like obviously something that cannot be separated from it. And the Catholic Church, its relations with science, and maybe some things might surprise. I don't know if the audience here, but maybe people online. So what are the Middle Ages? Let's start with the origin of the name. The Middle Ages is a general name given by scholars of the Italian Renaissance for the period between 476 to 1453. I'm using the AD because this is what's common in Europe. Here you will probably write CE, I think, Common Era. No, the reason for these dates, 476 is when the Roman, like the unofficial fall of the Roman Empire, and 1453 is the fall of Constantinople, and then more or less the lost knowledge of ancient times started reaching Europe, what was not taken by Crusaders and translated from Arabic to Latin, started coming more in the mid-15th century. So the idea of the name, Middle Ages, meant to represent the stagnation, narrow mindset in Western Europe, not only Western Europe, but mainly since the 5th century. And people in the Renaissance, they believe that they are reborn, they recreate the European culture and knowledge that was lost with the fall of Rome. Also, this period sometimes refers to the Dark Ages, which is much less in common use now, because we believe that cultural and scientific development either ceased completely or slowed down dramatically during this era. Okay. Does anyone know this painting? Okay, this is I don't know if you can see over there. It's an 1836 painting by British-American painter Thomas Cole. It is a series of 5 paintings. This one is the 4th, called The Course. The series is called The Course of an Empire. This one is Destruction, and this is the 2nd sack of Rome in the 5th century. So the first one was 410 AD, where the Visigoth sacked Rome, but the empire was able to continue existing. It wasn't the capital like long before that. And this is 455. The Vandals are sacking Rome. This is why we say vandalism as a like meaning of destruction and like ruining something beautiful. And so this is what more or less people, even today, in some cases, think of the Middle Ages, like destruction of Rome, and then just barbarians at the gates, or already past the borders. So the modern view in the Middle Ages, at least as far as the academy is concerned, is a bit more, I would say, forgiving. It will not be just an age of complete ignorance. It will be called the age of faith or the age of belief. But although most people did not know how to read and write, this is something that will continue even after that. So it's not something that is unique to the Middle Ages. In antiquity, most farmers couldn't read. Even city folk will not necessarily know how to read. However, there are 2 main definitions to the medieval time. I will state later what I prefer, but you can choose each. So first of all is the positivist or the more conservative approach, which sees the Middle Ages as either a European thing or a Mediterranean thing. So it can be applied on the Muslim world, North Africa, East and Western Europe, maybe Northern Europe, but definitely not Asia, because that's just too far as geographically. The influences are east to west and not west to east. So this is the positivist approach. The modernist approach or globalist, which is more like 19th, 20th century, sees the whole time as an era. So from the 5th century to the 15th century, this is why they will not call it the Dark Ages, because we know of the development in China, writing and fireworks and things like that. So this is a more global approach. It applies to all the known world back at the day. So obviously Sub-Saharan Africa will not be considered as medieval, no matter which approach. I personally prefer the positivist because based on everything that I will present, it is a very, very European thing, some influence on the Muslim world, but even the Muslim world itself has its own theme, its own way of thinking that doesn't necessarily correlate with what the Europeans believe. And both approaches will not use the Dark Ages anymore, with one exception. When we speak about the British Isles between the 5th to 7th century, where most written chronicles are lost, then you might see this term appears again, but it's not very common anymore. Any questions so far? Okay. All right, so the liberal arts, and I would start with the academy. So medieval Europe is the birthplace of the university in its modern form, which means it has nothing to do with ancient Greece. So the Academy of Plato has nothing to do with that. It's a clerical institution. It has some systems and subjects that have changed, obviously, especially after the Industrial Age, French Revolution. Engineering was not a distinct discipline, and all the things that we learn today, geography and things like that, that considered to be separate, then everything was taught all together through those liberal arts. The 7 liberal arts, Septem Artes Liberales, were considered the foundation of a free educated scholar. Free means that they think outside the box or without the guidance of the church. And these are the 7 liberal arts. Each art has the, I'm not even sure how they call it, like the virtue that goes along with it. So we have arithmetics, geometry, music, astrology, astronomy. I will discuss that, but you can see always in the background, there's the armillary sphere, always, and that's important for later. Logics, rhetorics, and grammatics. So there are 2 paths to the liberal arts. So each path takes the length of years as it is in the name. So the trivium, or the way of the tree, the place where the 3 roads meet, takes 3 years, and based on the name has 3 subjects mastered in this level, which are grammar, logic, and rhetoric. The idea is, without these understandings, going into deeper sciences, physics, mathematics, and things like that, music will be difficult for the student. Now, I did not write it here. It's very common that students or pupils, depend on how you want to call them, started around the age of 11 or 12. So 7 years, by the time they're 18 to 20, they're already graduating. And this is, today we will consider it as a bachelor's degree. So that's more or less the level. Baccalaureus would be someone who completed the 7 arts. It was believed that a scholar has to be eloquent, make sense of his speeches, and have sound structure to his sentences. Obviously, women were not allowed at this time until very, very late, after the Middle Ages, to go to the universities. So this will be all addressed in masculine. This is also where we get the word trivial, because it's the most basic thing you need to know. Now those 3 circles show what exactly each subject gives. So logic is the understanding of what and why. Those of you who study in engineering probably know what it means, why we still do logic, when something makes sense, something doesn't make sense, or contradicts something else. Rhetorics is about wisdom, knowledge, saying things. This is more for people who go and become lawyers later, well, advocates maybe at this time. You need to be knowledgeable of a lot of things in the world and understand those things deeply. And grammar is not just basic grammar, like knowing how to build a sentence. It's facts, data, terms, skills of constructing a sentence which is not too long and that gives all the knowledge needed to the listeners. And I'm saying listeners because readers were almost completely only belonging to the church. Those who mastered the trivium continue to the quadrivium, and you can all see that it means like the way of the 4 or 4 ways. This would take about 4 years to master, and that refers to the 4 subjects that are learned first by students who completed the trivial education. And these arts are arithmetic, geometry, music, I will discuss music in a moment, and astronomy or astrology. Why am I putting these 2? they would use, as you saw in the first painting, they would use astrology, because astrologia, the knowledge of the stars. We would use today astronomy to separate the idea that the stars have, the movement of the planets have any influence on the individual's life. So we do mean the same. When you see astrology, it means astronomy, just minus the influence on your own life. Now, music is unique because it doesn't really fit those other things like arithmetic and geometry are mathematics, astronomy is physics. What does music do here? So the idea of music is that represents the harmony of nature, and this is why it has to be in the higher level. If you don't understand the basics, you will not understand how nature works in harmony. And just like the circles for the trivia, we have this compass rose of the quadrivium. And we will see that the number 4 is very important at this time. And each duo represents a certain thing in nature. So astronomy and geometry are spatial and physical. I mean, you can see them, we can see triangles, we use them, squares, hexagons, pentagons, and astronomy obviously deals with everything in space. Geometry and arithmetic are static because they are merely numbers and shapes, and they are eternal. Like I will talk about sets of numbers later, but they just go on and on and on. They have no ending. Astronomy and music represent motion and changing. I think this is the most obvious because both the stars and the waves of music are moving and are changing with time. Music and arithmetic are non-spatial, so at the complete opposite of astronomy and geometry, and they are abstract. And this also should be, do you have a question? Okay. They're abstract because we can understand them without actually seeing them. Any questions so far? All right. I hope it means that everything is clear.
Well, I do have one question.
Yes.
Like I was doing some background reading on the history of science, and the earliest list of the liberal arts that I could find was Varro in the 1st century BC, and he listed those 7, but he also listed architecture and medicine. I'm just wondering why you think that those were dropped during the Middle Ages.
They were not, I'm not sure about architecture. Medicine would be studied after you complete your baccalaureus.
Okay.
So that it will not be dropped, it will just be a higher level. Okay. So once a person finishes his baccalaureus education, then he can choose if to just use it and be an advisor to a king or a duke or something like that, if to become an advocate and then go and study law or become a physician. I'm not using the word doctor because doctor is very, very clear. I don't know if many of you know, the meaning of doctor is the person who teaches. So a doctor would be someone who is going to study a doctorate in philosophy, have what we'll call a PhD, and then teaches other students either in a university or another clerical institution somewhere throughout Europe. Anything else? Okay. So the idea of science, what is science in the Middle Ages, and what scientific methods, and I would mean scientific methods because some of those things do make sense even today. So what is science in general? The term, as I said in the beginning of the lecture, cannot be tracked until the 18th century. So even very late after the Renaissance, scientific revolution, we call it scientific revolution, they did not. They all saw it in a different way. And they used to call it natural philosophy. The idea is that nature can be understood by thinking, by knowledge and thinking and visualizing things. This is how we understand nature. Before I go to the next sentence, can anyone know any very, very important piece in modern days that still use natural philosophy in its title, and is purely scientific? The Philosophia Naturalis Principia Mathematica. This is 1686, and even Newton, that we have no argue about him being a scientist, one of the most important physicists in the 17th century, still used natural philosophy in the title of his book. And this is one of the original books. I think it's in the National Library in London, if I remember correctly. And they still use, by the way, the date, it says 5th of July, but this is the Julian calendar because the UK at this time still did not adopt the Gregorian adaptation. The four elements. Since medieval times were very conservative, they were very preservative of the knowledge of the ancients, and in that sense, they did not change a lot until actually more or less the time of Copernicus. That would be what people understand. So if the ancients said that, with some exceptions that I will reach later on, we'll just accept it because, well, it has been true all along. Why would we change that? One aspect was the rejection of anything that cannot be grasped intuitively. If it's something that doesn't make sense, we'll just say it's not natural or it has nothing to do with our understanding of nature. So they accepted the idea of the four elements which the universe is conceptualized by. The light elements are fire and air, and the heavy elements are water and earth. Does anyone know which one is the heaviest and which is the lightest? Okay, so earth is the heaviest element because this is something we can see. Earth is the heaviest, then water, air is around us, and the sun is made of fire, so it has to be higher than the air. And here we have another sort of compass rose that for each element. First of all, I will start on the right. So each element has its counter elements, the dualism of elements. So we can see that water and fire, which is pretty obvious. And we see that their symbol is the same, just in reverse. Same is earth and air. And each combination of two elements creates some of our feeling during the day. So fire, which is the sun, and air makes you hot. Earth and air is dry. Air and water, humidity, is wet. And earth and water is cold. This is something that we don't need this knowledge in order to feel it and reach those conclusions ourselves. Now, this is something that goes back to ancient Greece, based on what you asked, that it not only represents, this is why astronomy is actually astrology, that the location of each planet in the sky when you were born will determine your personality based on which element influences you. So the fire will be more caloric, like summer, someone who is more I wouldn't say more settled, but more active. And air would be spring, which would be the people who they have more energy, blood, heart. And water are the phlegmatic people, the people who will try to reach some sort of trying to please everyone. And earth is the melancholic people, and they are also connected, each one to a season. Now, another thing that we can see in that the thinking of medieval time, I mean, it's not medieval thinking, some of it is going back to ancient Greece, but the idea was the same. We don't change anything. We have four four elements that are also represented in our modern knowledge of nature. So there are four states of matter that, if we look, they go from solid, earth, to liquid, water. So liquid is less heavy. I mean, today we'll not say not as heavy because of mass, but the idea was that you cannot just jump over. Okay, we will use this sublimination in this position, but they will not use it. It will just go from one state to another, and plasma actually represents the fire in the sky. Question so far? Okay. Natural and artificial existence, and this is something that is very interesting, seeing their perspective on the matter. So another aspect is actually the distinction between something which is natural and artificial. So in this sense, okay, I'll give you an example in a moment. French existentialism will use the term existence precedes essence, which means a human being is natural, an animal is natural, because first they exist, then they have some sort of a goal in their life. A chair will not become an existing thing without a human first thinking about it, then building it. So this is what artificial means. Okay, so this is more or less what I just said. So a ship or a clock, this is something that would not exist without human planning. So it's artificial. And that leads to observation versus experimentation. Today, an experiment is something which can give us valid results regarding nature. Back then, they would not accept it. If something is natural, then the only way we can determine it to be natural is by observing it. The experiments create an artificial environment and therefore is invalid to describe nature. One of the examples which I read and was very, very good to understand that, let's say you want to examine the behaviors of birds. If you keep the birds in a cage inside a castle, you will only know how they behave in a cage inside a castle. You will not be able to get a conclusion of how birds behave just generally. Only if you observe them without them noticing you, that would be considered as scientific approach. So in a way, Charles Darwin's drawings would be considered by medieval people as valid observation. They would probably reject the conclusions, but the observation, he was just looking, just painting and drawing conclusion from it. So the method, as far as medieval people are concerned, that Charles Darwin used was valid. Nevertheless, if there are some experiments or prototypes that help us create a machine that would help humans to build or drive or do something faster, that's okay. It's just not a natural thing. It's an artificial creation of humans. Any questions so far? It's all that clear? Okay. Glad to hear. So, medieval logic and mathematics. Today, we have 5 sets of numbers which we arrange in a certain way. And we need logic in order to describe how nature works. It's not just the observation, it's also need to make sense. So birds fly. Why only birds fly and nothing else? Because they have wings. So we need to apply logic into what we see in order to explain it. Now, today we use 5 sets of mathematics, each include the previous one. So we have the natural numbers, which are as ancient as they can be, all the whole positive numbers. We have the integers that include also the negative numbers and the number 0, which was introduced to Europe in the Middle Ages, but it would not be considered as a number, it would be considered as a concept. This is why if we think about it, 0 is something that we don't really need, and they would use a word, nulla, which still in some countries, nil or null will still be used as nothing, just empty. It doesn't represent anything. Then we have the rational number, which are the quotients of natural numbers. We have the real numbers that I will discuss because they have a very, very interesting approach to it because of at least 2 of the numbers that are here. And we have the complex numbers that were absolutely unacceptable in the Middle Ages. So this is how the sets are built. So the naturals are part of the integers, which are part of the rationals, which are part of the real, which are part of the complex sets of numbers. So the idea of natural numbers, in the very name natural numbers, means they represent something in nature. We use whole numbers to count. It makes sense. It's the most basic. We use our 10 fingers. Some will use also our feet fingers. So this is why we have unique numbers from 1 to 20, not necessarily from 1 to 10, but it's very, very intuitive and no need to expand. Also, by the way, I'm jumping over sets because I'm using the ones that were discovered first or understood first. So also the idea of fractions, which is already in the Bible, so it's way, way before the Middle Ages. And they could accept that if you cut an apple to half, to 2, you don't get 2 apples. You get half of 1 apple. So this is, again, this is something very intuitive. It's something that, and it will not be considered as an experiment because you just cut the apple and you're still doing something natural. Negative numbers is where things start to get a bit different. So they're very useful. And this is something that was, until the 19th century, you would not research something that is not useful. Okay, let's say you have a claim that you can prove that is right or wrong. Why would you do it if there's no application to it? So for negative numbers, there's clear application. For bookkeeping, a negative number means that you owe something. A non-negative number means that someone owes you. But, and this is something that we still use, it does not represent anything in nature. We cannot, if we have some reference, then we can have negative temperature and negative height and negative electric power, but it's not actually negative. It's in relation to the system. We have an absolute 0. We have an absolute height, and when we say that the height is negative something, it's in relation to sea level and not just negative height. It's clear that we're looking down, but the height would still be the same from sea level. Okay, and the very idea of complex number that existed since at least the Hellenistic time were completely rejected, at least in Europe. Muslim scholars, this is why I say that I will distinct Europe from the Muslim world in this sense, because the Muslims would at least try to understand them because of their uses. They will not be accepted in the West, I think, until the 17th century. Only in the 17th century, we will realize that we really have to use them. And today we cannot live without them. But back then it would be something that it would be a waste of time. Like, why would you research something that cannot describe nature? And as far as they knew, there were some attempts by Italians, one that I will also talk about in a moment, that tried to prove that they are useful for something, but he wasn't able to. Irrational numbers are a bit tricky. The example I give about them is like, it's like the Jews in Europe in the Middle Ages. We don't like them, we have to accept their existence. That's more or less the thing, because it is very clear that those two numbers are proven. There's no argument about their validity in nature. They are proven, and Does anyone know the story about the square root of 2? So the idea, actually, the two irrational numbers here, pi is older, but the square root of 2 is the first one to be proven to be irrational back when Pythagoras and his group, he presented the Pythagorean theorem, and then one of his disciples said, you know what, based on this theorem, if we take one side which is 1 and another side that is 1, the hypotenuse has to be the square root of 2, and there's no natural number that makes it. And they were very upset. Some say that they drowned him, some say that they exiled him, but people in antiquity, in the Middle Ages, they didn't like some things that cannot be explained with natural numbers. So this is why fractions are easy. There's 5/18. Like, I can understand that. But this is something that just goes on, and we cannot understand. And pi had some sort of close approximation. I think it's 27 divided by 3, if I remember correctly. Square root of 2 is something that they just didn't like at all. But those numbers exist, and they're useful, so we have to accept them. And Leonardo Fibonacci, some of you might heard of the Fibonacci series, and the golden ratio. He's the one who find the correlation between he actually explained mathematically the golden ratio. So he's a medieval Italian, and his research was focusing heavily on irrational numbers, and he showed how important they are to our day-to-day uses. However, he was not unable, even though he tried. He was educated by Muslim scholars as well, not only Christians. So he did try to get some sort of use of complex numbers, but it will take another, I think, 500 years after he died, where it will be finally understood fully and be used as it is today. So again, very clear why the square root of 3, square root of 2, those numbers, like, they exist in our day-to-day lives. So we cannot just say, well, we don't accept them. And this is a lesson based on the way they are dressed. I would guess that they might be Muslims, but we already see pi as part of a geometry lesson, maybe Italians. Yes.
There is a math professor in Australia who still doesn't accept irrational numbers. I like actually seeing some of his videos on YouTube. He's actually a really good teacher, but he just does not like the fact that irrational numbers go on forever. And he's like trying to figure out a way to get rid of it. It's really strange.
Since it has been over 3,000 years that people try to prove it, I don't know if he's going to get any different results. It just, even in the Middle Ages, they just gave it up. They understood that we cannot express it, and they would express those numbers up to, well, we would use today 3-digit after the decimal, but they would use fraction because they still wanted to see natural numbers involved. But I don't think he can. Maybe he'll surprise us all, but I doubt if he can, because it just doesn't make sense. This is why we call them irrationals. Anything else? All right. Infinity. This is, I don't know if it's surprising or not, but this concept was acceptable in the Middle Ages, even though it's not a number, it's a concept. And usually it describes God, which is above nature. So obviously we can accept, but also the idea of a limit that cannot be reached by mathematics. And we discussed it before, that this is eternal. Okay, it just goes on and on. Numbers can go on. You can always add something to a number and it will be bigger than the previous natural number. Now, my uncle had an argument a few years ago, which sounds a bit medieval, that once you reach a certain number, which is a natural number, if you add 1 to it, you're no longer describing anything in nature. But this is not how we define natural numbers. So maybe back then that could have been a valid argument, but today natural numbers are just whole positive numbers. That's all that it means. And the lemniscate, this symbol existed, but would not use to anything in mathematics until the 17th century, where agreeable symbols started to appear. And even in the 17th century, we still have the Newton version and the Leibniz. Only much later, all of those symbols will be accepted. Any questions before I go to probably the most controversial subject? Okay. So, is the Earth a plane or a sphere? So despite common belief, most medieval scholars accepted the Earth spherical and drew their conclusions about the Earth accordingly. I currently know of 2 scholars from late antiquity who did not accept it. And it took me 4 years to find their names. So it's much harder to find those who did not accept it than those who accepted it. And that's the main reason. This is a time of conserving the past knowledge. And the past knowledge, as the Roman, I think his 1st century scholar Pliny the Elder, he wrote Naturalis Historia, and he described the Earth as spherical. The Venerable Bede, he's a 8th century monk from Britain, was influenced by him, and he described the Earth to be almost a perfect sphere, and only the mountains and valleys prevented from being one. Modern knowledge that we have on the Earth is that if it was much smaller and we can hold it, we will not even feel those mountains and valleys. It will just be as smooth as it can be. Like it's very hard. Yes.
There's a person who told me that if you held a cue ball up to the size of the Earth, it is actually more porous than the Earth is.
Yes, that's exactly what I meant, but just the other way around. But yes, and also Bede. This is not in the presentation, but one of the things that he described, I don't know if it was De Natura Rerum or the other book. I read all of his works, like literally all of them. And he tried to explain a question that, like children's questions. Why do some stars blink? No, why do the stars blink? And why do some stars appear larger than others? So his answer is, imagine that you're in a cathedral and the ceiling is so high you cannot see the end of it. And you have lamps coming off the ceiling. The larger and closer a lamp is to you, it looks brighter. And the further away and the smaller it is, it looks dimmer. And that's 7th century. This is pure logic. He didn't have any telescope. He couldn't prove it in any way. Just pure logic, and a lot of this logic made sense. Some of it we still use today because it just works. It's not that they just rejected the way of thinking if the Bible does not accept it. It has some parts of it, but we will see that it's actually used to prove what they believed in instead of using it as the means to prove the world. Now, this is a 2-dimensional representation. I will show you in a moment something which makes more sense. But this is how the universe was actually, the way they believe that it's built. So the Earth is in the center, not because the Earth is the most important, it's just the Earth is made of earth, and it has a lot of water, so it's the heaviest. So obviously the Earth will be in the center. Then around it, we have air or the atmosphere, and above it, we have fire. Now, here is the first time that the Bible contradicts something with that, because they knew that the moon does not have its own light, so it's not made of fire. But since light is fire, then they could accept the moon being where it is above fire as part of the fiery heaven. And then we can see Mercury, Venus. So they were able to observe which ones are closer to the sun. Like this arrangement is exactly how we know it today. So Mercury is the closest because it moved fastest, then Venus, then the sun had to have the number 4 because it's a very important number. So the sun is in the middle, and then we have Mars, Jupiter. It's still in the Latin version, so Iois, and Saturn. And then we have the 3 layers of the stable stars, the stars that don't move, or at least we could not see them moving without the very, very advanced equipment we have today. And then we can see that the zodiac is influenced by them. And this is how you determine a person's characteristics based on when was this person born, what time of the day, what stars were in which constellation, etc. So this is what the Latin phrase around it say, and the English translation is the fiery heaven, because everything is in the fire stage, the dwelling of God, well, probably should be capital G, and all the elected. So everyone who goes to heaven, this is what it means. This is where they dwell above the 10 spheres. And this is probably how we should imagine it, okay? Like, anyone knows what it is? Yeah, it's called, well, in Russian, it's called matryoshka. I don't know how it's called in English, but the idea is that you open one, you have another level, and then you open until you have the smallest one, which is actually the Earth, and everything is above it. It's not just sitting down and everything is just covered like, how do flat earthers use? They use, I don't remember the English word that they use, but they use some word to say that this is how it is. It's not like that, it's just levels and levels and levels. Life on both sides of the earth. This was debated in the Middle Ages. Okay. So throughout the Middle Ages, probably since the 6th century, there were arguments about the existence of the antipods. Okay, antipodial dot is a place which is exactly the other way around on a ball or a sphere. And the main argument has nothing to do with the shape of the earth. It has something to do with Aristotle. So some accepted the Aristotelian belief that the equator is too hot to be crossed, and therefore no humans can cross it and live in the other side, because we have to remember they believe that all humans are originated from the same people. So they cannot just pop up on the other side unless God created them there. And the Bible said he did not. Now, others rejected this idea because it's pagan, and they were convinced that the journey is possible and there are people on the other side of the earth. And this is 1245, Gautier de Metz, L'image du monde. It represents how people actually can reach the other side of the earth. Of course, you will never do this journey, because what do we have on this side? The Antarctic. So it's frozen. We cannot reach that. It's too cold. But the idea is the same. You can just walk around the earth or sail or whatever. And Hollywood, in the service of NASA and the globalist lie. So this is John of Hollywood, or Johannes de Skrobosco, an Irish monk, who explained why and how you see certain buildings or ships. Of course, it's not to scale whatsoever, but the idea is that you are the observer from the window, and this is why you see the mast first before you see the rest of the ship. So that thing is as old as our knowledge. Like, people knew times and times ago that this is what happens. And he also has this armillary sphere. And okay, I'll give some explanation. What do you think they do with that? Because this is the 3rd or 4th time we see it already.
astrology.
And what, yeah, but what is that? No, that's the axis. That's the axis. So they knew that the Earth is tilted because it's visible. So they also took into consideration the tilt of the Earth when, let's say, you want to predict a solar eclipse. And by the way, this is a solar eclipse. A mistake in one day in a solar eclipse is why the Irish accepted the Julian calendar, because, well, there was, of course, a theological debate of who has the authority over the calendar, but eventually, this is what Bede says. It happens about 50 years before his time, that they watched a solar eclipse and the Irish calculations were one day ahead. And this is what convinces them that their calendar is incorrect. So, and this is like, if we ever use the term Dark Ages, this is the Dark Ages. So this is 6th century UK, Britain, nothing, no astronomical equipment, nothing but their own eyes and basic tables that they had for hundreds of years. Now, the shape of the Earth is very, very important, not only for Christian. This is a very essential subject for belief, because we need to know where we are, what we are, where we stand in the universe. So the belief probably throughout the entire land is that the Earth is the center of the universe. This is an unarguable question back then. But what does it look like? And it was very important. And its importance even influenced Jews, which are, it's a small minority in some countries in Europe or kingdoms. But they also translated Christian and Muslim works on the matters because it was even important to them. And let me see where it is. So one of the things that, again, Christian children ask is, everything falls. Why the Earth doesn't fall? I mean, we would feel if the Earth falls. So it's very clear that the Earth doesn't fall. And therefore, they use the Bible to explain it. And in this essay, questions about natural science or knowledge, really depends how you translate it. Adelard of Bath uses the scriptures to explain that the Earth hangs upon nothing. This is what the Bible says, just up there in space. It doesn't float or doesn't move. It's just static, but there is a space because it says in the Bible. And now the Hebrew version is saying the same, but it also say, like, if you take the last two words, it also means like restrain, like there's something that blocking it from falling. It's not only hanged upon nothing, it also has something that prevents it from ever falling to anywhere because there's nothing around it or below it. But there were also non-translated works. So Maimonides, in his Guide for the Perplexed, he lived in Muslim Spain, moved to Egypt. So this originally is in Arabic. So I had to check the Arabic, the Hebrew, and the English version to make sure that they are all the same, and they are. And this is what he says, and this is 1190. So this is like before any Copernicus or something like that. It has, however, already been proven that the Earth is in the form of a globe, that it's inhabited. And look what he says. He says that it's proven that it's inhabited on both sides. This is no longer a question. So he accepts the Christian approach on the matter of a center diameter, which is the equator, that both the inhabitants have their heads towards the heavens. This is very, very important. No matter where you stand, your head will always be towards the heaven and their legs towards each other. And yet neither can possibly fall, nor can it be imagined. For it is incorrect to say that one extremity is above and the other is below, but the term above and below apply to both of them as regards to the relative position to each other. Now, he was clearly educated by Christians and Muslims because most Jewish scholars did not deal with it unless they were educated by external scholars. So what he writes also applies to the Christian world and the Muslim world. Like, this was totally accepted. And this is something that almost every Jew have heard this name and know this work. So this is something that was never questioned.
Is it logical? I can't wrap my brain around
Why? However, why do we have a flat earth belief? So we'll start with a few quotes from the Bible, same Bible that we just used. And the Lord shall scatter them among people from one end of the earth, even unto the other, which shaketh the earth out of her place. So it means that it moves. I don't know why they use in the translation her, maybe because it's terra. And the pillars therefore tremble. So it stands on something. And gather together the spirit of Judea from the four corners of the earth, which correlates with some beliefs that the earth is like a box of some sort. Hast thou not heard that the everlasting God, the Lord, the creator of the ends of the earth, fainteth not, neither is weary? And the last one, which is probably the most problematic, from Daniel, that talks about the tower that can be seen, and the height therefore reaches unto heaven, and the side therefore to all ends of the earth. So if we take earth as the globe, that's problematic. How do you see it from the other side? There is, however, one problem with most of those verses, that the word earth used in the original text can also mean land. And we don't know what they actually meant. So this is King James Version. So this is 17th century. This is how they understood that. We don't know if that's correct. And there are many mistranslations in the Bible after the KJV version. So hard to tell. But what is the origin of the myth? So the idea that people in the Middle Ages believed the earth was flat is a modern belief. Even people in the Renaissance did not have this accusation. The earliest evidence I could find of this conception is 18th century Frenchman, the archaeologist Jean-Antoine Letron, and the historians of antiquity, Jean-Baptiste Gell. Now, why did I put there the subject that they were researching? They were not medievalists. They did not do medieval history. So even if they had the texts, they did not read them, they did not search, maybe they did cherry picking, I don't know. But that's the origin of what we know. However, the really influence of this belief started with an American, Washington Irving, who published alternative history fiction book. I don't even know how to call it, titled The History of the Life and Voyages of Christopher Columbus. And I'm saying alternative history because most of the things that are written there cannot be backed up by anything. We don't have any sources except what he said. We have only his word to what he describes. Okay. Now, the increase in popularity is because Irving lived in the age of Romanticism, and one of the things that Romanticism emphasized was going back to medieval way of thinking, which is a pure science, a science that is based on the senses rather than very abstract physics of mathematics. And this is the time that complex numbers are already accepted. We have It's a bit earlier than the discovery of electromagnetism, because that would be like late 18th century, around 1860, and the book comes out like 30 years before. But this is where popularity gains. It becomes more popular because people stop understanding physics. Like if I tell you that something falls because it's heavy, okay, it's clear. But suddenly you tell me that it falls faster here than on the moon because the moon is smaller, I cannot understand that. And modern flat earth societies also use the same argument. Just use your own eyes, just use your own logic. Can you see the curvature? No, because I'm 6 feet and the earth is enormous. I will not see the curvature no matter what. I would have to be 100 kilometers in space in order to see that. But his success did not die, and even in the movie 1492, Conquest of Paradise, which was 500 years to the first voyage of Columbus, Ridley Scott put it in his movie. There's a scene where in the University of Salamanca, Columbus argues with one of the clerks, and he puts his hand on a globe, and he says that he was taught that it's as flat as the table. And like we can argue about early Middle Ages. In the 15th century, no one, absolutely no one, would have thought that the earth is flat. And he was heavily criticized about it, saying that his movie is a fiction and not historical, because he was relying a lot on Washington Irving. And just for you to understand, it's not just a book, it's a whole, man, it's 4 books. I think in total, it's like 1,200 pages. So I was sure it's like a short book, and then when I saw the 4 volumes, it's like what's his name, Gibbon, Edward Gibbon, the decline and the fall of the Roman. This is more or less what he was trying to mimic. So, any questions?
My mind is blown. So definitely in that time period, that historical era of Columbus, that argument never happened.
I will show you that it stopped happening way before that, but in his era, this was simply non-existent.
So this is a good early-ish example of a lie being told so much, so well, and so often that most of us were educated to believe that happened then, that those arguments happened during the time of Columbus. That's part of why he did the exploration, was to disprove the spherical nature of the earth versus the flat earth.
These are, I don't know what to tell about these arguments, because I couldn't have this lecture for 4 hours and give you maps with curvature from the 10th century, but it'd just be too long. I will also refer to something that is, I think I have like 4 or 5 more slides before I reach that. How even the church thought of those, they had some knowledge that there is at least islands next to where we know that America is, because there were Viking settlements in Newfoundland, and that's 10th or at latest 11th century. And it lasted at least 20 to 30 years. And some of them were Christianized later because they came from Iceland. But I don't know why it started. And people, I don't even know if he intended to write it as just a fiction or as actual history. He's not alive to tell us, but people just accepted it. And in the 19th century, you had people who believed that the stories of the Bible actually happened in America, because you cannot prove that in the Middle East there are any 4 rivers coming together in one point. In America, you can. You want to ask something?
Is that the same Washington Irving that did the legend of the headless horseman?
I think so. Yeah. I'm almost certain. This is like early 19th century, 1830, something like that. So yes.
I'm pretty sure I'm triggered on that name as a fiction writer.
Okay, so it's even worse. Like you take a fiction right there, but this is also like when I have arguments with people about ghosts versus aliens, we do not have any indication of people meeting aliens before the 20th century. there would be reports that they saw ghosts. But then suddenly when science fiction starts, people started claiming they saw aliens, and then they report less of seeing ghosts because, well, ghosts is superstitious, but aliens are real. Extraterrestrials, yes.
And that carried on. I was unfortunately having a conversation with a coworker the other day, and he was showing me the hieroglyphs in Egypt that looked like helicopters and spaceships and all that, and that's proof that there were.
These are moderns.
And it's like, no, I said, no, it was abstraction. Early art was abstraction. So we wanted to look like what we have seen since, but that doesn't mean that's what it was then.
But
We kind of visualize, we want something to fit our concept of what we wish for that to be, whether it is.
or it's modern. There's a church, well, a cathedral in Europe that you can see an astronaut. And like, oh, look, in the Middle Ages, they knew it. No, it's modern. They just put it in the 60s because of the space program. It's modern, and we even know the date when they put it there. You wanted to ask something? Yes.
I heard on the issue about Europe being spherical. The thing I heard about this was that they knew it was spherical, but they didn't know the right size of it.
Oh, well, even the right size that they didn't know, they didn't have the way to measure. Some used the old, what his name is, Aristophanes calculation, but they would not be able to accurately calculate the size of the Earth because it's spinning. So it will always be a little less in the poles than in the equator. But they could predict the solar eclipses based on the knowledge that they have. So they had some rough estimate of the size. Otherwise, they could not predict the right time of eclipses. Even though it depends also on the moon, but you need to know what point on the Earth do you stand, and if you can see the eclipse. First, if you can see the eclipse at all, if you can see only partial one, or if you can see a full one. And if I remember, his name was Robert Grosseteste. He was a cleric in the 11th century. And when he discussed on how we see eclipses, he said that because of the curvature, when you stand in England, you will see a full eclipse. When you stand in Italy, you will see only partial, and in India, you will not see it at all because the whole Earth is blocking your vision. But they had to know that at least India is far enough not to be able to see it from there. Anything else? Okay. Isidore Civil and the etymologies. So that's another thing that is a bit problematic because of the translation and the meaning of what they wanted to, of how they describe things. So just 1 second. What? But he's a clerk. He's the Bishop of Seville. So published before 1625, we don't know the exact date. Isidore, the Archbishop of Seville, so he's not a woman, wrote a 20-volume long etymological encyclopedia titled Etymology, and he tried to explain the origins of names. Well, it's pretty obvious from the title. This opus deals with the scientific knowledge which survived in Western Europe, because this is like less than 200 years after fall of Rome. And this is what they tried to do because everything was in either Arabic, Greek, or inaccessible languages. So the idea was to write something in Latin that can be used throughout Latin Europe. So, for example, this is how he describes atoms in book 8. Atoms are what philosophers, natural philosophers, I should have put it in brackets, call certain corporeal particles in the world that are so tiny that are not visible to sight and do not undergo tome, splitting. Hence, they are called atomoi. That's literally exactly how, okay, not exactly, but almost exactly how we describe an atom. That is 7th century, beginning of the 7th century. And this is knowledge that they had in the Christian world before that. He later adds that sometimes when you have like a sunlight in your room and you see like the dust, he would call this the atoms. So this is incorrect, but the idea is the same. You cannot see it unless it's a very, very tiny particle of everything. And this is the problematic term, orbis terrarum. So what technically orbis means? Either circle, ring, or disc shape. And for describing the Earth, he would use orbis terrarum. Now, in modern translation, they would use the word globe, but they would use it because they knew, based on other works of his, that this is what he meant. But it technically says circular lands. So the globe, this is a modern translation. The globe, orbis, derives its name from the roundness of the circle because it resembles a wheel, hence small wheel called small disc. Pretty indisputable evidence that orbis terrarum means a flat plane, which is a circle. However, this is what he meant. This is not a map. This is a representation of the known world. So we have Asia, which is larger than Africa, known Africa, so Northern Africa, and Europe, known Europe, so no Scandinavia or something like this. This is not something that you take in order to navigate in sea. This is just a representation of how the known world is. Now we have here in the middle, and this is why he ignores a lot of other lakes and seas that we know. So there's the Mare Magnum Fiume Mediterraneum. So this is the Mediterranean Sea, and around it is the ocean. Okay, Mare Oceanos, Oceanum, and the four sides of the Earth. So Orient, East, Occident, West, North, and South. No. Yes. But then we have this map. Typus orbis terrarum. This is clearly not flat. Can anyone guess the year of this map? We already have like North America and everything. You're close enough. 1570. Now, here is where still some ancient thinking is still here. Terra australis nundum cognita. The southern land still unknown. And later on, when they discovered Australia, it will be called Antarctica. And Antarctica is in the maps in Europe 200 years before any human being have ever landed. We have any proven landing of any human being on the Antarctic continent. So that was just the idea that it has to balance, but they still use orbis terrarum because this is the orbis, this is the land, and it's round. But in a 2D representation, this is the only way you can draw it. So this is not so obviously this is the Mercator, how do you call it? Projection. So it's very clear that it's not flat, but this is what they mean when they say orbis terrarum. Also, we're close to Easter. In Easter, the Pope says, urbs et orbis terrarum. So to the urbs, to the city of Rome, and all the people of the round land, but it means the earth. Questions before we continue? It was, but some people, they're still looking for, like you see, they say orbis terrarum, and orbis is a circle, so it's a circle, but they still use it then. They just use it, it's just like natural philosophy. they kept using it because that was determined. Why would we change it? And only after the French Revolution, which was very extreme, and I don't know how many of you know, they changed everything. They changed the weeks, they changed the months. So instead of having a 7-day week, 7 is a holy number, it would be a 10 days week. 3 weeks in a month of 30 days, and then 5 days of celebration in the end of the year, no holidays, nothing like that. Christianity was prohibited, so this is why they started using other terms. But I mean, natural philosophy, man, we could have used it today, it would still be the same. Okay, so the Catholic Church and science. I mentioned the church a few times so far, but how was it connected to science? So first of all, we need to understand it's not exactly class. Maybe if you're Marxist, you would say classes, but this is more like the estates, the way things were ordered. So the estates of the realm were the oratores, or the people who pray. So on the left are the clerks. And then we have the bellatores, the people who fight, the knights, the nobility, and laboratores, which are mostly everyone else. So the clergy, it's well known that incorrect that it interfered and controlled scientific research. And I'm using the term a bit problematically, but I will show in a moment why it's not exactly the case. So the fact was quite the opposite. Universities are ecclesiastical institutions. Terms we still use today as far as universities are like a dean or a rector. These are ecclesiastical terms, and their students were part of the clergy or the first estate. However, there was a distinction between scholars who specialized in theology and those who focused on natural philosophy. And you were not allowed to just, if you are a theologist, you cannot explain nature. And if you're a natural philosopher, you cannot deal with theology. That's very simple. So the separation meant that theologists cannot just tell you that this is how nature works. You're a theologist, stay in your seat and just deal with God and the scriptures and things like that. Leave the engineering to the engineers. You just, I don't know, you're the bookkeeper, do your thing, don't interfere. And vice versa. And natural philosophers were only allowed to explain why, but not how. Whenever universities, not the church, intervened in the teaching, it was the theologists who felt that the natural philosophers are leaving their handmaiden status in order to interfere in something that they shouldn't, and this is their problem. And one of them is Galileo. So do you know the case of what actually happened? So in the 17th century, Galileo published a dialogue concerning the two chief world systems, 1632, something like that. And just the title, dialogue. So he discussed it. And while he discussed it, he also gave his own interpretation of what the scriptures actually say, and that he shouldn't do. So this is why he had a trial, and he was sent to house arrest, and he was allowed to keep doing research, scientific, natural philosophy related research while in house arrest, but he was not allowed to leave Italy, or I think he lived in Venice. In the Kingdom of Venice. If I remember correctly, if you find online something else, then it is what it says there. And that was why he was trialed, and his book was prohibited because of that. You interfered with something that you should not. And there were condemnations for some teachings between 1210 and 1277 during the 13th century. The theologians wanted to remain the control over interpretation. And the University of Paris, which was one of the most important universities back in the day, decided to slowly prohibit the teaching of Aristotle because it contradicted the Bible and the teaching of the church itself. However, ironically, this act actually caused natural philosophers to question the teachings themselves, something that they did not do for 600 years. It just, well, it's Aristotle. Everyone knows it. We brought it with the Crusaders from the Levant. We translated it to Latin. We know it's true. We can prove it, but there are too many things that did not work out. And one of the things that really concerned natural philosophers at this time is the epicycles. Does anyone know what it is? So the way that the planets are moving, they go in a certain way, then they go back, and it's like, I don't know. I'm sorry? Yes, yes. They go back and then they continue their travel throughout space. And they had some explanation to it, like they have like an extra circle around their path or something like that, but it needed corrections. It needed corrections every 100 years or so because of the movement of the Earth. And eventually they said, why do you need to correct something that has to be static? It has to be correct. Like, why do we correct it every time? And then we have to contradict something we said before. And this is eventually what would lead to the abandoning of the system altogether. It will take another 200 years, but that is where it started. Still at the church, this is Gerbert d'Aurillac, known better as Sylvester II, Pope Sylvester II, from the end of the 10th century, the first millennia. And he was teaching mathematics. This is geometry. This is one of the books that he was writing and teaching. He came from the Kingdom of Castilla, so very close to the Muslim world, gets some knowledge being transferred on these areas. This is why at those times, Spain or the Iberian Peninsula and the Apenninian or Italian Peninsula are the location where most Christian scientific knowledge is located, because this is where the Jews and the Muslims work with them and give them knowledge from one way to the other, so they can compare their findings with someone else's. And also there are ports there, so ships coming from the east, from China, from the Ottoman Empire, not at this time, but I mean generally why these places were more sorry. Okay, we talked about that, and although lost to Europe since the end of Greco-Roman era, he reintroduced the armillary that we saw a few times already to Latin Europe through the Islamic civilization of Al-Andalus, which back then, today Andalusia, back then was still part of the Western Emirate of Abbas, or whatever it's called. He also credited for the invention of the first mechanical clock shortly before his death. He's the one who introduced zero to Europe and the Arabic numerical system, which we still use today. So that's the end of the first millennium. He died like right after, 3 years after the first millennium. And again, we already discussed it. So this is from medieval time. The paint drawings that we saw were a bit later. This is from medieval time, how this device actually looked back then. And I really hope that most of you were like those students instead of this one. And if you have any further questions, I would be happy to answer. All right, then we're done as far as I'm concerned.